Good morning, all of you. Last lecture we have seen one numerical on the eccentricity. Today we have taken one example on the square chimney. Okay, you have given the different application. On the basis of that different application, you have to solve the numericals. Here I have taken the example of the square chimney. What is the given? See, here is a one square chimney is given having the internal dimension is 1.25 meter is given. 1.25 meter by 1.25 meter this dimension is given. Okay, square chimney is given. This B and D dimensions are same. Okay, having external dimension is 2.5 meter by 2.5 meter, and the pressure intensity at on the projected area is equal to 1.3 kilonewton per meter square is given. Okay, pressure is given on that projected area. Okay, and height of the chimney you have given the 12 meter. Also, the specific weight of the chimney is given 22 kilonewton per meter square. Then what we want to find out? We want to find out the maximum and minimum stresses at the base of the chimney. Then how to calculate the maximum stress and minimum stress? You know, we have seen some example before that. See, maximum stress is equal to, you have to think the reverse direction. Okay, what is the sigma max? We know here is a, we want to find out the bending stress, direct stress as well as bending stress. And what is the sigma minimum? Sigma minimum is nothing but the sigma D minus sigma B. Okay, means we want to calculate the direct stress as well as the bending stress. Then you will get the stress at the base of the chimney. Then how to calculate that? Okay, here is a specific weight is given. Okay, then how to calculate the weight of the chimney? Yes, weight of the chimney. We know the weight density. Specific weight means what? You have given the weight density of that chimney is at 22 kilonewton per meter square. Also, we know the volume of that chimney. Volume of that chimney. With the help of that, you can calculate the weight density into volume of the chimney. With the help of, you can calculate the weight. Once you have got the weight of the chimney, then after that you can calculate the direct stress act on that chimney. Okay, how to calculate the direct weight act on the chimney? Yes, anybody? Can you tell me? You know the weight of the chimney. Once you have calculated the weight of the chimney, then divided by the cross-sectional area of that chimney. Cross-sectional area of the chimney means you will get the formula, this specific weight into the height. This you will get the direct stress of the act on the chimney. Once you have got the direct stress, then you can calculate the total wind pressure act on that chimney. Total wind pressure. How to calculate the total wind pressure? You know the coefficient of the wind pressure. Okay, you know the coefficient of the wind pressure. Coefficient of the wind pressure for the rectangular or square block as given 1. Okay, this value is denoted by the C, capital C. Coefficient of the wind pressure C is equal to 1 for the rectangular, and if you have given the circular, then you have to consider the 2 by 3. This is the standard coefficient of the wind pressure. You know the wind pressure is given, how much wind pressure is act on the projected area, 1.3 kilonewton per meter square. Means how to calculate the total wind pressure? Total wind pressure is equal to coefficient of the wind pressure into this pressure is at, okay, 1.3 kilonewton per meter square into the projected area, into the projected area. Then how to calculate that projected area? Okay, AP is this value into the height. Okay, you have to calculate that. We will see the details. First we want to calculate what we know. We require the area. First is that we require the cross sectional area. How to calculate this cross sectional area? Here the square is given. We know that. If we are given the square, then we can write the formula b square minus small b square. External minus internal. Okay. Area is equal to, what is the b square value? Capital B 2.5 meter square minus 1.25 square. Okay, if you have solved this, then you will get the 4.6875 meter square. Okay, you will get this area. Once you have got the cross sectional area, then you can calculate here the direct stress. How to calculate that direct stress? Already I have told. This direct stress is nothing but sigma T is equal to, you know that this value is given specific weight into area, cross sectional area into height divided by cross sectional area. With the help of this formula, you can calculate the direct stress act on the chimney. Okay, what is the formula? Specific weight into the volume. What is the volume? Area into h, height. Area into height means area is known, then height is also known, then this specific weight value is known, then we can calculate this rho into h is there. Okay, what is the value of that? 22 kilonewton meter square. This is given. And what is the value of the height? Is it 12? Then if you have solved, then you will get the 264 kilonewton per meter square. Kilonewton per meter square. This value you will get 264 into kilonewton per meter square is there. Okay. Then next one is we want to the, once you have got the direct stress, one value we will get. Then how to calculate the bending stress? You know the bending stress is nothing but sigma b is equal to, we have seen the m by z. Then again how to calculate the z value or m value? We will calculate the z. This is the sectional modulus. Z is nothing but the sectional modulus z. Okay, how to calculate the z for the square? If you have given the square shape, then how to calculate the z value? Yes, anybody? B, capital B by 4 minus small b by 4 divided by 6 into capital B. We know that z is nothing but the I by y. I by y. What is the I for the moment of inertia for the square? A raised to 4 divided by 12. If you have calculated this, and what is the y bar? Y bar is nothing but the maximum distance divided by 2 is there. Okay, 2 is there. Okay, that's why you will get the b raised to 4 minus small b raised to 4 divided by 6 into capital B. You should put the value in this equation. What is the capital B? Capital B is a 2.5 raised to 4 minus 1.25 raised to 4 small b into 6 into 2.5. Then you will get the sectional modulus. Z is equal to 2.44. What is the unit? Meter cube. Meter cube. All of you know this. Okay, what is the unit of sectional modulus? Z is equal to, because what is the unit of moment of inertia? Meter raised to 4 and divided by y. What is the y unit? Meter is there. Okay, that's why you will get the meter cube, sectional modulus. Then we want to the calculate. Also, we require the value of total air pressure act on this given chimney, square chimney. Then how to calculate that total pressure? I will write the total pressure. Total pressure is denoted by PT. I will take the P suffix T. Okay. This formula coefficient I have coefficient of wind pressure. Okay, there is a wind pressure, coefficient of wind pressure Pt is equal to, I will write coefficient of the wind pressure into wind pressure into what? Projected area. Okay, all of you getting how to calculate that total pressure act on the chimney? See, I have taken the coefficient of the wind pressure. What is the coefficient of the wind pressure? If the wind is act on the square shape, then you have to remember that this for the plane you have to take the C value is equal to 1, and for the circular shape you have to take the value C is equal to 2 by 3. Remember that. Okay. Then what is the value of PT? I will write the formula first. Coefficient of the wind pressure C into what is the wind pressure is I will write P suffix D, wind pressure, into what is the projected area, AP, A suffix P. What is the projected area? What is the C for the plane section? Is 1. I have taken C is equal to 1. What is the wind pressure? Wind pressure is given 1.3 kilonewton per meter square. And what is the projected area? Projected area is nothing but you have to consider that projected area outside. 2.5 into 12 is there. Okay, where is and this check that this projected area is 2.5. This square section is given, right? 2.5 into height up to this pressure is at we have considered that projected area 2.5 into 12. Then you will get the PT is equal to 39 kilonewton. Okay, all of you getting how to calculate that projected area? Okay, getting this for if you have given the circular shape, then you have to consider C is equal to third. Okay, then once you have calculated the PT, then easily you can calculate the movement at the base. Okay, movement at the base. I will erase this side. Check that. Movement at the base. How to calculate the movement at the base? Movement at the base of the chimney. It is denoted by the M. M is equal to, you know that movement is equal to total pressure into H by 2. Okay, we have take this H by 2 is the distance of its application of the projected height. Okay, H by 2 is nothing but the application of the projected height. H by 2. Up to that half distance we have considered the pressure is at. Okay, then you will get the movement is equal to PT is nothing but what? PT is total pressure. Already we have calculated 39 kilonewton into H. What is the H? H is 12 by 2. M is equal to, then you will get the if you have calculated, then your M is equal to 234 kilonewton meter is there. Okay, this is the movement at the base. Once you have calculated the M and Z value, then easily you can calculate the bending stress at the base. You know the formula, bending stress is equal to M by Z. What is the value of M? 234 divided by Z is equal to 2.44 is there. If you have calculate this, then you will get the 95.9 is there. This you will get the unit kilonewton per meter square. Kilonewton per meter square. Once you have calculated the sigma B and sigma D value, then easily you can calculate the maximum stress and minimum stress. You know that the stress is equal to sigma max and sigma minimum. Sigma max is equal to, I will write sigma D plus sigma B is there. What is the sigma D value? We have calculated 264, na? Yes, plus what is the value of sigma B? 95.9 is there. Then you will get the sigma max 359.9 kilonewton per meter square. And what is the value of sigma minimum? How to calculate this? Sigma D direct stress minus bending stress. Put this value here, and again you will get the value for the minimum stress at the base of the chimney. This one 168.1 kilonewton meter square. Okay, all of you getting how to solve the numerical? Okay, I have taken the application of the square chimney. Related to that square chimney, you know the formulas. Which formula? What is the weight of the chimney? How to add the direct stress? Then you have to find out the total wind pressure. You know the which area is the projected area. Okay, that projected area, how to calculate that? This outside area 2.5 into height is there. Okay. Also you know the how to take the coefficient of wind pressure. Okay, see, for the plane section you have to take the C is equal to 1, and for the circular section you have to take the two-third value. But here is a rectangular section is given, that's why I have considered the C is equal to 1. You know how to calculate the value of bending stress and direct stress. This two value you will give the value of maximum stress is at the base of the chimney and minimum stress is at the base of the chimney. Today we will stop here. Next lecture we will see again some numericals.